So, properties of parallelograms, that will be what we talk about today. And parallelograms are the most important quadrilateral because a lot of interesting properties of a parallelogram carry over to the other quadrilaterals. Okay, so a parallelogram is a quadrilateral with two pairs of parallel sides, meaning that opposite sides are parallel. So we can mark that in like so. Those two opposite sides are parallel, and these two opposite sides are parallel on this parallelogram. And then what's interesting is if we were to draw in a diagonal here, which acts as a transversal, some interesting properties of parallel lines occur. Similarly, the same with this diagonal as well. So, let's kind of mark in some interesting things. One thing that's interesting is actually opposite sides are congruent. That is an interesting property. Opposite sides are congruent. Similarly, well, not similarly, but another interesting property is that opposite angles are congruent. Since we do in fact have parallel lines here, we know that these two angles, this is our transversal and these are our parallel lines, these two angles are supplementary, these two angles are supplementary, these two angles are supplementary, and these two angles are supplementary. We know this is true because same side interior angles are supplementary. So the way we can say that is adjacent angles are supplementary. And remember, that's because of same side interior angles being congruent. And one other interesting last thing is that the diagonals bisect each other. So that's another interesting feature. So we should write that in as well. The diagonals bisect each other. So these are all important properties of parallelograms that you must have memorized. So we're given a parallelogram, and we have to prove that the opposite sides of this parallelogram are congruent. So first things first, let's kind of draw a parallelogram, and let's give it some letters here, if you will. What sort of letters should we give it? Well, let's give it like I don't know, A, B, C, D. That'll be a good way to orient ourselves. Okay, so they said we're given that we have a parallelogram. So the first thing we should mark on a diagram whenever anyone says we have a parallelogram, and that rhymes, is that opposite sides are parallel. And that's actually how we're going to begin our proof. First things first is we'll say that AB is parallel to CD, and BC is parallel to AD. And why are we going to say that? We're going to say that since we are given a parallelogram, so opposite sides are parallel. So by definition, opposite sides are parallel. Alright, so now from here, we do know actually if we draw in a transversal, we do know that these two angles are congruent and these two angles are congruent. And you might ask yourself why? Well, that's because if we have parallel lines in a transversal, we all know by now that alternate interior angles are congruent. So that'll be the next line of our proof. We can say angle BCA is congruent to angle DAC since alternate interior angles are congruent when lines are parallel. Okay, so now where can we go from here? Let's just say similarly, so by the same logic, not only do we have a BCA and DAC, but we also have DCA that's congruent to angle BAC by the same logic. They are also alternate interior angles. Okay, so notice how I'm marking things in as I come up with them. In addition, AC is congruent to itself, and you should remember this from back in the day. This is by the reflexive property. So you might be wondering, why am I jumping through all these hoops? Well, my goal now is to prove that I have two triangles that are congruent, and then last but not least, I'll be able to say that opposite sides are congruent because corresponding sides of congruent triangles are congruent. Alright, so let's say now, or finally, triangle ABC is congruent to triangle CDA. And why is that? Well, that's by angle, side, angle. Notice how we have an angle, a side, and an angle, or angle, side, angle. The side is in between the two angles. The side is in between the two angles. So that should make good sense by now. Keep in mind, you will have to write proofs on your midterm, so this is good review. It's by angle, side, angle. So then, as a result, now that we've proved that the triangles are congruent, we know that all corresponding parts are congruent. So we can say AB is congruent to CD, and BC is congruent to AD, since corresponding sides, you have to say sides there, of congruent triangles are congruent. Thus, in a parallelogram, opposite sides are congruent. So that's kind of cool that you can start with just the fact that opposite sides are parallel and then come up with all these other interesting things in a parallelogram. So now that we know all these properties of parallelograms and we feel confident that we can kind of even prove some of them, if someone says to you that you're given a parallelogram or given anything, you have to react to that immediately. So if someone says to me I'm given a parallelogram, I'm going to mark my diagram up completely. So what do I know? Well, first off, it's a parallelogram, so I know opposite sides are parallel. That should be like a duh sort of thing. But I also know that opposite sides are congruent. We just proved that. We also know, think about the properties on the first slide of this lecture. We also know that the diagonals bisect each other. So those two diagonals are congruent. Oh, that's going to be interesting. I'm going to even write down that equation right now. So in marking up my diagram, equations are just like jumping out at me. Like x squared plus 3x equals 5x plus 15. Why? Because the diagonals of a parallelogram bisect each other. So each of those lengths or distances is congruent. Let's call this t right here. We know that gt is congruent to to, since the diagonals of a parallelogram bisect each other. So you have to make equations that are true. Similarly, the other equation that kind of jumped out at me is I know opposite sides are congruent. Not only are they parallel, but they're congruent. So I can get y right away. Okay, so that will be this equation right here. I know 2y plus 36 equals 4y plus 12. So now from here, we can certainly solve for y. So now you as a student, since you should feel pretty confident in this material now, in order to get full credit on your homework, you're going to have to solve for y here. You're going to have to solve for x here and factor. Yes, you need to be able to factor on your own. And then you might even have to reject one of your x values, because if you plug it in, you might get a negative side length, let's say. I want you to plug in your x's and y's everywhere, and then think carefully about what it means to be a parallelogram. so that you can finally answer this question. Find x, y, EM, GO, and finally the perimeter of this parallelogram. So this is part of the practice for you. So we've really set you up for success on this one. In addition, to get full credit on your homework, we have some practice here for you. Not only do you need to finish the last problem to get full credit, but we want you to mark up this parallelogram completely. If I say you're given that you have a parallelogram, there's a lot of things that you should mark in. I will start you off by reminding you that it's a good idea to mark in the diagonals. So if you need to, look back in your notes at all of the properties of what it means to be a parallelogram, and we want you to mark everything in on your diagram completely, and then even state all of the properties. And what I mean by that is state the properties specific to this diagram. So for instance, you could say, since this is a parallelogram, WZ is congruent to XY. That's one of the properties that I want you to state. I want you to state a bunch more, though. So mark your diagram completely and then state all properties. Get in the habit of, when you're given that you have a parallelogram, to mark it up like crazy, just like we did at the beginning of this lecture. Good luck. Make sure you do everything that is requested of you, and have a glorious day.